Welcome all. I am Dr. Kakoli Banerjee, Associate Professor from JSS Academy of Technical Education. Today we will be discussing about the page replacement algorithms. Now this page replacement algorithm is a very important topic when we talk about the virtual memory concepts in operating system. Now in operating system we know that virtual memory is a topic that cannot be avoided. Virtual memory is something that we always require when we are executing processes that are bigger in size, bigger than the size of the RAM available. So whenever we have this virtual memory concepts coming into our mind, the first thing that comes is in our mind is the page replacement algorithms. Now when we talk about the page replacement algorithms, first we need to understand what is memory. Memory can be categorized or classified broadly in two parts or two categories. We say that memory, a part of memory is the main memory and the part of it is in the secondary memory. Now the main memory forms or is the RAM of the computer, whereas the secondary memory, when we talk about it, it is either the hard disk of the computer or it is the secondary storage devices that you connect with your computer. So memory is basically classified into these categories. As we all know that the main memory as compared to the secondary memory is smaller in size. So what happens if there is a process that requires more memory than what is available in our main memory? Can we execute that process or we have to leave that process? So the answer is that we implement virtual memory concepts. Now what is virtual memory? Virtual memory is basically an extension of the main memory. A part of the secondary storage device is converted into main memory and the part of a process resides in the main memory and a part goes into the secondary storage, right. And whenever the process, when it is under execution, it requests or demands something that is stored in the main memory, the operating system brings those things into the main memory. So this is based on the demand during execution of the process. Now let's say that the secondary storage is divided into pages in form of pages and the space available in the main memory is in form of frames. So what happens that a process which is under execution, it will have some pages in the main memory and the remaining will stay in the secondary memory. So whenever a process that is under execution requests something, some pages from the operating system, what the operating system will do? It will remove some pages from the main memory and it will bring some new pages into the main memory. So when we talk about this type of page replacement, so it clearly says the page replacement algorithms decide which memory page is to be replaced. So basically what are we doing over here? We are trying to find the target page, which is going to be the target page which we are going to remove from the main memory, and in that space we are going to bring a new process in the main memory. The process of replacement is sometimes called swap out. So this is the term that we use for this replacement process, where the operating system is selecting a particular page, removing it and bringing a new page into the main memory. Page replacement is done when the requested page is not found in the main memory. So when do we go for page replacement? Obviously page replacement is being done when that particular page which the process is requesting is not available in the main memory, right. So these are the three common page replacement algorithms that we will be talking about today in this lecture. First is the first in first out, the most well known algorithm, the most well known concept. The second one, least recently used, LRU. Third one, optimal page replacement algorithm. So, all these three are the most common page replacement algorithm. Apart from them, we have the most recently used page replacement algorithm and least recently used page replacement algorithm. But if you understand these three algorithms, all the other algorithms will be clear to you. So, before we move forward, we need to understand what is a page fault, although we have defined page fault over here. So, let us see actually what is page fault. So, basically a page fault occurs when a program attempts to access a block of memory that is not stored in the physical memory or the RAM. That means, a process is trying to access a part of itself, but that part is not available in the RAM. The fault, now this is a page fault because it has searched for something and it did not get it. So, when this fault takes place, it is a process which notifies the operating system that it must locate that data in the virtual memory that is there in the secondary storage, right. It is either on the hard disk or on the other secondary storage devices, to search for that data in the virtual memory and bring it into the main memory. So, this is what is page fault. Very simple to understand. Whenever it has not found its page in the main memory, it requests the operating system to find that page in the secondary memory and bring it into the main memory. So, this is page fault. Like page fault, we have page hit also. Now, what is page hit? Page hit is basically whenever a process is requesting for a particular page and that page it has found in the main memory. So, that condition is called a page hit condition. Okay. Now, starting with the page replacement algorithms, the first one, as I have already told you, is the first in first out page replacement algorithm. Now, what is a first in first out page replacement algorithm? As the name says, from the name only you can clear it out that the first page which has entered the main memory, that means the oldest page, will be replaced first. So, first in first out, in case of first in first out, what does the operating system do? It searches for the oldest page in the memory. So, the target page which is going to be removed from the main memory is going to be the oldest page. So, it is, as the definition says, a FIFO replacement algorithm associated with each page, the time when the page was brought into the memory. So, what is the basic difference between FIFO and other page replacement algorithms is that in FIFO, when the page is coming inside the main memory, it has a time attached with it. This time tells you that how old the page is, right. And when a page must be replaced, the oldest page is chosen, that is the page which was loaded or which got into the memory first. So, there is a difference between FIFO and other page replacement algorithms. The basic difference is that in FIFO we have a time tag attached with each page that is coming inside the main memory. Now, let us see how this page replacement algorithm actually works. Okay. Now, over here there is a incoming stream of pages. Now, these are all individual pages. So, let us consider them as page numbers. Let us say this, for the time being, let us consider them as page numbers. This 7 is a page number, 0 is a page number, 1 is a page number, 2 is a page number, and so on. So, let us consider them as page numbers. That means, the process that is under execution, it is requesting for these pages. Now, what is specified? The frame size. The frame size tells you how much availability of memory is there in the main memory. That means, if it is saying that the frame size is 3, that means only 3 frames are available in the main memory. So, whatever data you require, whatever pages you require, they can be filled only in these 3 frames, right. And this row is basically going to tell you that whether we are going to have a page fault or not. So, initially the memory is empty, the process starts executing itself and it starts requesting the operating system for the pages it needs for execution. So, the first page that it needs for execution is 7. So, 7 is not it is not available in the memory. So, what happens? A page fault takes place and the operating system brings 7, page number 7 from the secondary memory to the main memory. So, 7 comes in. So, you can see over here this X is telling you that a page fault did take place. Next we have 0. 0 is also not there in the main memory. So, what will happen? The operating system will try to bring 0 inside the main memory. So, what is happening? Till now we are having space left, we still have 2 frames left where the upcoming pages can come in. So, what will happen? There will be one more page fault and this 0 is inside the main memory. So, over here also a page fault took place and 0 came into the main memory. Next requirement is 1. 1 frame is still empty. So, what we can do is easily this one page number 1 can be brought into this particular empty frame. So, you can see this 1 got into the empty frame and there was a page fault. Now, till here everything was okay. Why? Because we had free space and we have brought our pages into those free frames. But now all the 3 frames are full. Now, what we have to do is, for bringing any new page into the frames, we have to replace some pages, already existing pages. So, what was the concept of FIFO? It tells about the oldest page, it talks about the oldest page. So, which was the oldest page that came into the main memory? 7 was the oldest page. So, we have to remove 7 first. So, for bringing page number 2, we are going to replace 7. So, you can see over here this 7 is replaced with page number 2, rest of the pages are intact. So, over here also there is a page fault. Coming to the next page, requirement of page number 0, but this is a page hit condition because 0 is already there. So, you can see over here there is no page replacement because 0 was already there in the main memory. Coming to the next page requirement 3. So, what do you think? What should we replace? Now, which is the oldest page in the memory? The oldest page over here now is 0. So, we are going to replace 0 by 3 now. So, you can see 3 has replaced 0 because it was the oldest page in the memory. So, again a page fault has taken place. Moving to the next page 0, it has replaced again the oldest page in the memory which was 1. Coming to again 4. Now, what do you think, what should 4 replace? It will replace 2 because now 2 is the oldest page in the memory. So, you can see 4 has replaced 2. Similarly, we will keep moving forward. FIFO is a very simple algorithm to implement. It just searches for the oldest page in the memory. So, you can see over here at every point we are trying to find the oldest page amongst the 3 frames that are there in the main memory. So, at every point you can see over here 0 was required, 0 has replaced 4. Why this 4 because 4 was the oldest page in the main memory. Similarly, this is a page hit because 3 was already there in the main memory and there was a requirement of 3. So, there is a page hit which has taken place. 2 is also there, again a page hit. Now, 1 is not there, so we are going to replace 1. So, over here you can see 1 has replaced 2 because in these 3 frames 2 was the oldest frame. Now, again 2 has replaced 3 because 3 was the oldest frame, 0 was already there in the main memory. So, we are not replacing 0, 1 is also there in the main memory, no replacement required, again 7 is required. So, we are going to replace 7 with 0 because 0 is the oldest page in the main memory, followed by 0 again. So, 0 is replacing 1. Why? Because now 1 is the oldest page in the main memory, and lastly we are again requesting for 1. So, 2 is getting replaced by 1. Why? Because now 2 is the oldest page in the main memory. So, you can see how many page faults were there. Our main motive of implementing these algorithms is basically to reduce the number of page faults. So, you can see over here we have 15 page faults, right. So, we will try to reduce the number of page faults in the algorithms that we will discuss after this. So, this is clear, very simple to implement. We are just trying to search the oldest process or the oldest page in the main memory, and we are removing the oldest page. But FIFO is costly in terms of page faults. So, let us now see the next algorithm that we have, which is known as the LRU, least recently used page replacement algorithm. Again we have taken the same incoming stream. The reason behind taking the same incoming stream is to make a comparison in terms of number of page faults. So, we are going to compare the number of page faults and see that in this given scenario which algorithm is best suited. Again we are having 3 frames available. So, now what do we do in least recently used? That we look at the background. So, we look back that which are the pages that were recently used, and we are not going to replace the pages, or we let us say we are going to retain the pages which were recently used, and we will remove that page which was not recently used, right. So, let us see, it will be more clear with the example. So, starting with 7, obviously right now the memory is empty, we are not having any pages in the memory. So, 7 comes in with a page fault, 0 again comes in with a page fault, and 1 comes in with a page fault. Till here everything was okay because we had free space in the main memory. So, there was no point of replacement. Now, there is a new requirement of page number 2. When we require a new page, now what we will see is these are the pages that are there in the main memory. So, recently we will try to search for the recent usage. Recently 1 was used, so we will retain 1. Recently 0 was used, so we will retain 0. So, the least recently used is 7. The least recently used is 7. So, now our target will be page number 7. So, 7 will be replaced by 2, right. So, 2 has replaced 7. Why? Because 7 was the least recently used page. Again coming to the next requirement, 0. So, 0 is already there. So, it is going to be a page hit. So, no replacement required. Coming to the next one, 3. Now, when we require 3, we will look backwards in this direction. And while looking backwards, we will see which were the recently used pages. 0 was recently used, so 0 we will retain. 2 was recently used, so 2 we will retain. The least recently used was 1. So, we are going to replace this 1 with 3. So, this is the method that we follow while making the replacements for your LRU page replacement algorithm. We use the same method, again 0 because it is there in the memory, we are not going to go for any replacement. Coming to 4, this 0 and 3 have been recently used, so 4 will replace 2, right. Similarly, 2 has replaced 3 because 4 and 0 were recently used, right. So, this is the method that we follow for your least recently used page replacement algorithm. So, you can see the number of page faults have reduced by what? By simply implementing the technique that we are looking backwards. Whichever process has been recently used, we expect that the same set of processes will be used in the future also. So, depending on this technique, we implement this page replacement algorithm, and if you see in number of page faults, the number of page faults have also reduced. In first in first out, the number of page faults were 15, now the number of page faults are 12. Moving to the next and the most important page replacement algorithm, the optimal page replacement algorithm. Like in LRU, we look backwards, but in case of optimal page replacement algorithm, we look in the forward direction. That means, we look for the future. So, instead of searching for processes whether they were recently used or not, we search for processes which are going to be, or we search for pages which are going to be used in the near future. So, we start with 7, 0, 1 as it is. Now, when 2 is required, it will search that which are the pages that are being used in the future. So, 0 is being used in the future immediately after this, 3 is being used, so 3 is not required, 0 is not required, 4 is not required, 2, 3, 0, 3, 2 and 1. So, we find a match over here. So, 0 and 1 will be used in the near future and 7 will be used much later than it. So, what we will do is we are going to replace 7 because 0 and 1 were recently will be required recently, right. Similarly, when we talk about this 3, 0 was already there, so we did not go for a page replacement, this was a page head. Now, when 3 is required, it is searching that 2, 0 is immediately required, 2 is immediately required. What is required later on? 1 is required much later on. So, we are going to replace this 1 with the new request 3. So, the basic difference between the this algorithm and the rest of the two algorithms that we have seen is that this looks for the future, this predicts the future, and according to the requirement of the future, the pages are targeted. So, we move forward. So, you can see how drastically the number of page faults have reduced. So, we have very less number of page faults because what is the main reason behind it? The main reason is that we are looking for the future, and whatever is required in the near future, we are retaining it, and whatever is required much later in the future, that we are replacing. So, this is the optimal page replacement algorithm, and number of page faults is 9, which has reduced than the first one, FIFO, and the LRU page replacement algorithms. So, these were the 3 page replacement algorithm. For the timing in this scenario, our best replacement algorithm is the optimal page replacement algorithm. Moving to the next topic, this is an anomaly, or this is a problem that takes place when we go for page replacement algorithms. This is known as the Bilet's anomaly, and this is basically the rate of page fault varies directly with the number of frames allocated to individual processes. The number in the number of frames considerably decrease the number of page faults. So, it basically says that because the number of frames are less in the main memory, that is why we are having more page faults. So, if we have more number of frames in the main memory, it will result into less number of page faults. But Bilet's anomaly takes place when even after increasing the number of frames in the main memory, the page faults even increase. So, it is there are many conditions, there are many examples that you will find where increasing the number of frames have actually increased the number of page faults, right. And this is a exception that takes place, and this is very rare to find, but it also depends upon the page replacement algorithm that you are using. One more important thing that we have in page replacement algorithms when we talk about it, it is the concept of thrashing. Now, what is thrashing? Basically, we know that a part of the process is in the main memory and a part of it is in the secondary memory. So, when the process is under execution and the main time, the major portion of the time is being spent by the system in servicing the page faults, and very less processing is happening, or let us say negligible processing is happening, this condition is known as thrashing. So, over here in the graph you can see that the number of page faults is increasing, the system is increasing, the number of services that the system is providing for the page faults that are taking place is going high, but the actual processing is going down. So, from this point thrashing is taking place. Till here processing was improving, the throughput was high. So, this condition is okay, this is what is expected, but from here number of page faults have increased, and because of the increase of number of page faults the processing has gone down, and this system is now going into a condition known as thrashing. So, thank you.